Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll see about implementation of logic circuit using only NOR gates. Before we start actual logic implementation, let us revise about NOR gate. We have symbol of NOR gate. We have two input, that is A as well as B, and we have output, that is Y. We can write a Boolean expression for the NOR gate. In case of NOR gate, we know that output of OR gate is again inverted and then it is known as a NOR gate. So Y is equal to A plus B, that is a Boolean expression for the OR gate, and when we add complements or when we add bar A plus B bar, then it becomes a Boolean expression for the NOR gate. One thing we should notice at this stage that we have given input A and B. So at the output we have A plus B bar. So whatever input we give, it may be, for example, A bar and B bar. Output Y is equal to A bar plus B bar and whole bar. We'll be using De Morgan's second theorem also while implementing logic circuit with the help of NOR gates. So theorem 2 or second theorem of the De Morgan, and it says that the complement of a product equals the sum of complements. For example, we have complement of product. This is product A dot B and complement of A dot B. So complement of product equals sum of complements. So we have A plus B, but it is a bar plus B bar. So sum of complements. So complement of a product equals the sum of complements. That theorem will be using while implementing our logic circuit only with the NOR gates. Now let us take one example. We have been given switching function, and that is C plus D bar dot A bar plus B bar dot B bar plus D. So we can see that it is a POS type of Boolean function or switching function. POS, that is known as a product of sum. So we have sum term, we have three different sum term, and it is multiplied together. So it is a POS type of Boolean function, and we can apply only NOR gates when switching function is given, that is in POS type. We can see that it is not a standard or canonical POS, but it is normal POS, but again we can apply NOR gate to implement the given switching function into logic circuit. We use one of the property of Boolean algebra, that is F is equal to F double bar. So when we apply double bar, when we complement any function two times, if we invert and again if we re-invert, then we get the original. So that property will be using with this given switching function. So we write our switching function and then we apply double bar. One is a blue whole bar and one is white whole bar. After applying double bar, the value of switching function F remain as original. Then we apply De Morgan's theorem. We apply De Morgan's theorem for this indicated portion. We keep white whole bar as it is, and with the blue whole bar we apply De Morgan's theorem. Now we can observe that it is a complement of product. We have three sum terms, but it is a multiplied together. So it is a first product, second product and third product, and it is a complement of a product. So now we apply De Morgan's theorem and then see all the sum terms. Before applying De Morgan's theorem, all the sum terms were connected with dot, but now it is converted as a summation, so with the plus sign, and then we have to apply complements. So now we can see that complement of product is converted into sum of complements, and white whole bar we keep as it is. So this is our final converted equivalent to original switching function, which we'll be using for the logic circuit implementation, but now we'll be able to implement the logic circuit only with the NOR gate. So we have written again our switching function. Now we apply NOR gate first as a NOT gate, because we have input A, B, C and D. But in some place we require A bar, B bar and D bar. So we apply first NOR gate as a NOT gate to get A bar, second NOR gate to get B bar. We do not require C bar at any place, so we will not convert C into C bar. But we require D bar, so third NOR gate we use as a NOT gate to get D bar. We use a NOR gate for all the sum terms. So C plus D bar and complement. We use a fourth NOR gate. Then for the another sum term, we use a fifth NOR gate. And the last sum term, we use a sixth NOR gate. And the entire function that is also connected with the plus sign. So for the entire function, again we use a seventh NOR gate. Given switching function, it was in POS form, product of sum. But now after applying De Morgan's theorem, we can see that we have plus sign everywhere. We have sum term, original sum terms, but now it is connected with the plus or summation or addition. So now it will be very easy. We can use only NOR gates everywhere. Now let us start implementing our logic circuit. We have first input, that is A, input B, input C and input D. Now we use a NOR gate as a NOT gate to convert A, B and D input into A bar, B bar and D bar. So we use a first NOR gate to get A bar, second NOR gate to get B bar and the third NOR gate to get D bar. Now we can see that we have 4 input A, B, C and D is available. At the same time we have A bar, B bar and D bar also available, which we can use as an input to the NOR gate. We use our fourth NOR gate and at the input we have C and D bar. So output of the NOR gate, that is C plus D bar, because as an input we have given C and D bar, but output of the NOR gate, that will be C plus D bar whole bar. Same way we use a fifth NOR gate, input A bar plus B bar and whole bar. Sixth NOR gate, input B bar and D. So output of the NOR gate, that is B bar plus D and whole bar. So now we have 3 intermediate output is available. We use another NOR gate with the 3 input for the summation of all the intermediate outputs. So we have 7th and final NOR gate. We connect output of intermediate NOR gate to the input of the 7th NOR gate. And we have output Y of the 7th NOR gate, and that is equal to our original switching function. So this way we can convert any logic circuit which is in POS form using only NOR gates. If switching function is not in POS form, then first we have to convert switching function into POS form, and then we can apply implementation using only NOR gates. Thank you for watching my video. Keep watching. Thank you very much.